Welcome to BKW Physics. I'm Mr. McConley, and today we're going to talk about why do you use significant digits in scientific notation, and how do you do it? So I'll just write it as abbreviated as Sigs. So when you're dealing with Sigs, what's the point here? So I pulled out an example or two here that I hope is going to help you kind of see the reason for doing this. Say as an example, say I gave you three numbers to add up. These are three numbers that someone maybe measured. 6.753, 1.07, and 5.00. And I asked you to add those up. Now before I go ahead and add, because the adding's trivial, I know you can all add, but before I add, something that you guys in the room have learned about in lab is that when you measure something, the last place that you write down on your paper, for instance, I'll circle it in red to highlight understanding here. The last place that you write down is you're unsure of it, therefore it's a
guess.
It's a guess. Thank you. So it's a guess. So you're kind of like, well, I kind of think it's a 3, but someone could convince me it's a 4 or a 2, maybe a 1. So, and I kind of think it's a 7, but I'm not really super certain about that. See, so these are guesses. Those are guesses. So if the reds are guesses, then let's now follow through with our addition. So when you add with a decimal point, remember you just add straight down. So you go 3, 3, 7 and 5 is, yell it out like you know something. Alright. 12. So when I add this up, I get 12.823. Fine. So a lot of you would just say, well, I'll just write it down like that. It's 12.8, that's my answer. That's what the calculator gave me. If you did it on the calculator, that's what it would give you. However, now let's think about our guesses. If the 3 was a guess, then the 3 is a guess. If the 7 and the 0 were a guess, I don't care if the 5 you're sure of. If you're sure of something and then you take 2 guesses, what does it leave you with? A guess. And this is kind of disappointing now, because now I'm only sure of the 12.8, and after that, it's pretty foggy, because those are guesses. And in fact, this one's really foggy, because this one's based on that one. You know what I mean? Like, those are guesses. And what is our rule that we learned in lab about how many guesses you can have in a number? 1. You can only have one guess in a number. So if I'm adding a number and I'm getting 2 guesses, this is not possible. This doesn't work. I can only write my answers with 1 guess. So my answer would have to be I can only write it with 1 guess. Now, no one wants to spend all the time like thinking this through when you're doing a problem, so here's the shortcut to it. If you look at numbers and you're adding or subtracting them, and this is 2 places past the decimal, and this is 3 places past the decimal, you have to take the least accurate one. So this one's less accurate because it's only 2 places, so my answer is only going to have 2 places past the decimal. Done. Okay? But this is the logic behind why you do it. Now, a similar example would be if you multiplied some stuff. Like this. Say you were taking the number 3.22 centimeters. Let's not even worry about the units. Let's not confuse things right now. We'll do that another day. It's 3.22 and you're multiplying it by 2.1. Before I get into the multiplication part of it, what are my guesses? Well, in the first number, this is a guess. And in the second number, that's a guess. Now, if I were adding, I would just write my answer to the tenths place, right? Because I would take the least significant, and this one would be the least significant. But that rule doesn't apply so much when you're multiplying. When you're multiplying, you got to look at the number as a whole and say, how many significant digits does this number have? So you ask yourself, how many Sigs? Question mark. So how many Sigs does that have? according to our Atlantic Pacific method, we would start on the Pacific side and we would go 1, 2, 3. So this has 3 sigs to answer my own question. What about the next one? This has 2 sigs. So what do you think my answer has to have in terms of sigs? Just 2. So my answer is going to have 2. But let's kind of follow through on the work here right now. So we multiply 1 by 2 and we get a 2. 1 by 2 we get a 2. 1 by 3 we get a 3. Placeholder. 2 by 2 is 4. 2 by 2 is 4. 2 by 2 is 6. Okay. Yeah. 2, 6, 7, 6. 3 decimal places there. So if you do it on your handy dandy calculator or long, you're going to get that answer and you're going to think, that's my answer. And I'm going to say, no, it's not. Because if you multiply a guess by a guess, this is a guess. A guess by a non-guess, a guess. A guess by a non-guess, a guess. Those are all guesses. Sorry. Then you go to the next line. Well, the 0 is just a placeholder, so really we don't even need it there. But non-guess by a guess gives you a guess. Those you're sure of. Good. Now we add. This is a guess. This is a guess. This is a guess. Geez, the only thing we're sure of is the 6. Everything else is like up in the air right now. How many guesses can you have? 1. So, yeah. Now I just heard that. Someone said 6.7. And you would be, no.
6.8.
You gotta look at it, you say, I need only 1 guess, so I'm gonna stop right here. But unfortunately, my next door neighbor is a 6, which is gonna round this up to a 8. So this is really gonna be 6.8, and this is 2 sigs. So the shortcut is, because no one wants to show all this work and figure out where your guesses is, that's ridiculous. Okay, the shortcut is, when you multiply 2 things together, you gotta look at how many sigs each one has, take the lower one, and your answer can only have the lower one. So I said this had 2 sigs, my answer can only have 2 sigs. Done. And that's significant digits for today. Physics.